There we go. Okay. Okay, so 53 is good. All right. Why don't we do, how about we do one from like each of the sections, and then we can go back and do more. That way we make sure we kind of hit everything.
Okay, you pick the hardest.
Okay.
No, pick the one that's the most like the exam.
Well, I don't
Kevin,
want to keep looking at the exam.
Hell, you know, it's a good idea.
Well, okay,
Came up
let's
with it.
do 54 for sure. We'll do that one, and then we'll do one of the trig ones.
It's raining so hard here. It's crazy.
Can you see that? 54?
Yep.
All right, go ahead. Roll it out.
Okay, hold on. That's 2 times.
You do top minus bottom.
Top minus bottom, yeah.
Oh, my.
Oh, Haley, your dog's being bad now.
What's the answer? History.
I got 256 over 3.
Oh,
Okay.
What
Was that a dub, Kevin?
No.
Wait, what is, you got your derivative, I mean your antiderivative as 4/3 x to the 3 halves, right?
Uh-huh.
Okay.
What? I did something wrong.
Okay, well, Kevin, did you...
Hold on.
Okay, hold on.
You got 256 over 3?
Yes, ma'am.
Oh.
Team Haley.
That's why I got it wrong. Okay.
You see what you did?
Yeah. You really just say Team Haley.
No. No, I didn't.
Yeah. What? I still didn't get it right. What?
Okay, well, what did you get for... Did you do your antiderivative right?
2/3 x to the 3 halves.
Oh, because you forgot. There's already a 2 in the front. So it's 2 times
Oh.
2/3.
Eh.
Silly Kevin
Man.
Harris.
Guess what I did today, Miss Mac?
Bake me a
Okay.
cake?
I mean, I can.
Well, didn't Fuller say it's illegal or something?
No. Fuller's wrong.
I don't know what she's talking about.
She says not know what she's talking about.
She really does. I'm just kidding. Love you too.
Yeah, she's going to watch this and be like, what the heck? Okay, I want to do this trig one, and then I'll let you guys do 56 on your own. Does that sound okay? Or maybe we should do 56.
Yeah.
I think 56 is harder. Okay, you do 55 on your own. We'll do 56. I mean, it's not really that much harder. What'd you say?
March later.
You complaining again?
Kevin said he's not good on his.
He's not going to do it because he's a freaking slacker. You know what would be so cool, Kevin? If every time you were a slacker, you got taller.
I guess that would be kind of cool, wouldn't it?
It would be cool. I mean, that's probably why you're so tall now.
Yeah.
Burn. Sorry. Okay, let's do 56. I'll give you the answer for 55 was 12.
Whoa.
But we're gonna do 56.
All right, Miss Meg.
All right, Haley.
I got it.
Lauren, you're muted.
What's the answer to 54?
54 was 256 over 3.
Okay.
Is that your friend that left her phone? Were you texting and driving?
No.
You swear?
Okay, I was at a stop sign.
Okay, no, Lauren Douglas, we don't do that.
Well, I stopped once I realized how bad it was raining. Oh my God, it's bad out there.
Yeah,
Yeah.
that's probably a bad time to drive home.
Is that the answer at 56?
No, that's the problem for 56.
Oh.
Secant tangent. What's the derivative? What is it?
So what
Secant.
gives you a derivative of secant tangent?
Secant.
Secant.
Ooh, I'm confused.
All right, and then you're plugging in 3 pi to the 4th and negative pi over 4, and I bet you can just straight up plug those into your calculator.
You know, 3.
Well, actually, they're not so nice, so maybe not.
No,
Because
they're
you'll
not
get a
nice at all.
decimal. Okay, so what I did for this one is I thought about the fact that secant is the same as 1 over cosine, right?
So 1 over cosine.
Yeah, so then what I did was on my unit circle, there's one in the front of the book, you can look and see what is the cosine value at 3 pi over 4 and what is the cosine value of negative pi over 4. And both of those are 2
Square root 2.
square root of 2 over 2. This one is negative, and then this one is positive.
So 0.
But since secant is 1 over cosine, essentially what we would write down is 1 divided by the square root of 2 over 2 and 1 divided by the negative square root of 2.
Wait, square root of 2 over 2. So it's what? 7 times 1 over square root of 2 over 2 minus.
Well, I would simplify this before you multiply by the 7.
Wait, is 3 pi over 4, is that positive?
That one's
Square root of 2?
negative
Oh, okay.
because it's in quadrant 3.
Do we add them or subtract? I forgot.
You are going to subtract them. So you're going to do 7 minus the first one and then 7 or times minus 7 times the second one.
Negative 14 over square root of 2
Yes.
plus 14, or minus 14 over square root of 2?
Yes. Now just rationalize that denominator.
You got negative 28 over square root of 2 and then times square root of 2 times square root of 2.
Wait, how are you doing that?
Okay, so are you with me, Kevin, with how I got these from my unit
got
circle?
you there.
Okay, so then if I do this, essentially that's going to give me negative 2 over the square root of 2, right? If I just do this division. So I'm going to say 7 times negative square root of 2 over 2 minus, this one will be 2 over the square root of 2. So 7 times that one. So that's giving me negative 14
negative 14 minus.
over the square root of 2 minus 14 over the square root of 2, which gives me negative 28 over the square root of 2. And then we go, ew, that's so gross. Let's rationalize. So multiply both the top and the bottom by the square root of 2. And then we'll end up with negative 28 square root of 2 over 2. And you can simplify that to be negative 14 square root of 2. Bada bing, bada boom.
Yes.
Dub. Okay. All right. I want to do number 57 because there's one like that on your final. I remember that. And then probably one of the 58, 59, 60. But one of them was more, no, I'm thinking of something else. 59 was a little bit weird. So do you guys want to do 57, 59?
Yeah.
Okay. Beep, 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 beep.
Oh,
What's this
terrible at substitution.
formula?
What?
The substitution formula.
Oh, it's like using you.
Oh. Okay. So U equals 4 r squared.
Yeah, that's what I did.
So D would be 4r.
Yep. Okay, so Haley wants to do u equals 4 plus 2r squared. So then we take the derivative. So that's 4r dr.
Good job.
Okay, so then we have 4r d. Oh, this one doesn't work.
So would you just 1 over the
You would
square
just
root of
write du here, because this is what du equals.
So it'd be du over the square root of u.
Yeah,
That's
and
it.
I think I actually, I did my, I dealt with
So-
u first. So I said u was, so we have du over the square root of u, right? So then I
No, no.
turned my u into u to the negative 1/2, bringing it up. And then I integrated that.
Is this the
So-
one where you bound the new bound?
Yes, we're gonna do that too.
Oh.
You're just ahead of me. Okay, so if I integrate u to the negative 1/2, what are we gonna get?
2/3 the 3/2.
2/3.
No, stop.
Stop, you
It's
stop.
2.5. So then it'd be 2. 2
Yes.
u to the 1.
Yes, good. Did you get that, Kev? Ooh, I just called you Kev. That's weird. Okay, so we have 2u to the 1/2 du, and we're going to do the new bounds like Haley said. How do we figure out what our new bounds are?
You plug it into u, right?
Yeah, so you're going to plug your 0 and your 1 into your formula here to find your new bounds. So what are the two new, I'll give you a second to do it.
Wait,
Six-
into the U?
Not
yeah,
into
6
the u part, but into what you said u equals. You're going to plug the values of 0 and 1 into r.
Oh,
All right, I don't think I said that very clear.
no, you're fine. It's just 4 and 6.
Yes, good. All right, so now we don't have to re-plug back in. We just are going to use those new bounds.
What do we do with the du?
Yeah, that's what I was
Uh,
wondering.
Oh,
You just-
I don't really think I even needed to write that. No, I didn't need to write that because it, yeah. So 2 minus 2.
Do we just get rid of the du?
Which 2?
The
The
DU.
du.
Yes, the du, sorry. Yes, we didn't need that to write that part. Just was getting excited.
How does it just go away?
Shut up.
Well, because we did the integration, so it goes away. I just got excited and wanted to write it down again, I guess. Okay, so you can simplify this though. What do you get for a final answer?
Wait. Do you put it in decimals?
No, don't put it in decimal. But you can simplify this. What does this simplify to?
8. I mean, no, 4.
Good. So your final answer is 2 square root of 6 minus 4. Because the square root of 4 is 2, 2 times 2. And then that's it. Up, 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 up. Okay. 59?
Wow. Nice.
59 is a little tricky.
Cotangent egg
Wait,
to the 5th egg.
Yeah, this one's a little, I don't know. I guess I got excited or something.
You thought we were like smart or something.
You guys are very hardworking. I don't like to say smart. Well, because smart just makes me feel like I just don't like to. Because I feel like when people say like when people think that you're smart, they feel like you shouldn't have to work hard to get what you want, and that's not, I don't agree with that.
But
Does that make sense? Like, I feel like if you work hard, it's not about being, I don't know, naturally smart. It's about putting in the effort. Anyway. No?
I agree.
Okay, good. Okay, so for this one, what I did, and I don't think there's actually one that is this tricky on your exam.
you can show us the exam, we can see.
None of you laughed. I thought you were gonna laugh.
At what?
I showed you the back of it.
Oh, we couldn't see you.
Oh. Yeah, there's not any that go to the 5th. So this one's trickier than the ones on your exam, but if you can do this one, then you're a beast. Okay. So for this one, what I did was I said that u is going to be cosecant x. And then I took my derivative of cosecant x, and what's the derivative of cosecant x?
Oh, tangent cosecant.
And it's negative.
Yeah.
Okay. Now this is the part that's kind of wonky because I don't even think no, we weren't in school when we did integrals. Okay. So I forgot my dx and I should have written that down. All right. So I know I have my dx, right? And I kind of have a cotangent and a cosecant as well over here. The only thing that essentially I'm missing going from here to here is having the negative, right?
Mm-hmm.
So what I want you to think about doing is dividing this whole thing by negative cotangent cosecant. And if we were to do that, the cotangent would essentially go away. And then what would happen here? How many would I have?
To the 4th.
Yes. Okay, good.
So you get negative cosecant to the 4th?
Yes. So negative from the negative sign here. And then all we're going to do now is write in our u, because we said u was going to be cosecant x. So we're going to have negative u to the 4th. And then what we're going to do is we're going to integrate that, but we need to find our new bounds. So how are we going to find our new bounds?
Plug it into the original u.
Yeah, so plug in pi over 2 and pi over 6 there. And those two you can plug straight into your calculator. Your calculator will give you the nice numbers for those.
How do you get?
You didn't get nice numbers? Oh, Kevin, you got a haircut.
No.
Well, since the last time I saw you, yeah, because I only saw the top of your head last time.
Cosecant
I got 1.
over sine?
Cosecant is 1 over sine, yeah.
You got 1 and
So 1.
2.
I got 1 and 2 as well, yes.
Dog.
Okay, and so it'll be.
Okay, so go ahead, integrate that.
Oh, never mind. I got it.
Is it okay that the bigger number's on the bottom?
Yeah, because you keep these consistent, and that's how these were plugged in, and yeah, don't freak out.
15.
You got 13? What?
15.
15?
Negative 1/5 u to the 5th, right?
Yes, good. Negative 1/5 u to the 5th.
Oh, I forgot you had that.
Oh, did you not integrate, Kevin?
Yeah.
You silly Billy.
2 times 2 is 4, 1 times 2 is 8. 32.
Well, Douglas, I'm kind of sad that you're graduating at the same time that my nephew's thing is happening.
Really?
Yeah.
That's
Wait,
okay.
when
Come to mine.
Can you watch them live or something?
My nephew?
No, them graduate.
Oh, I don't know actually.
Doubt it.
Miss May, did you get 31 over 5?
I did.
Wow. It looks like I don't even need to take the point.
Well, I mean, you should, yes, still take it.
I'm just, it was just a joke.
Oh, you definitely opted into your grade thing though, Haley, twice, and Lauren Douglas, you did it 3 times.
Good stuff. Lauren, let's go. Overachievers.
Wait, I did it
Wait,
for one class 3 times?
No, you did it for stats twice.
No.
And they were like right after each other. So I guess you did stats, you did calculus, and then you did stats again.
Fools.
Okay.
Probably.
Let's see. You should do 60 on your own.
What's
Well, because I thought we were going to skip around so that we could make sure we get to everything, right? That was the plan?
we can say we do it.
That looks kind of hard.
Well, I mean, if you just want to do all of them, we can do all of them. And just, if we run out of time.
No, let's come on. We're good.
Yeah, okay. You do 60. The answer is 6. Can't be that hard if the answer is 6.
That definitely can.
All right. 61 was a really big pain in my butt because I messed up my signs.
Oh, God.
Well, it's only because I was trying to go too fast. And I just.
This is in chapter 6.
This is starting, I think this is actually chapter 5. The area? Or is that chapter 6? I think it's chapter 6. You're right, Kevin.
Yeah.
Yeah, so this is, we should probably do, like, all.
Okay. That's fine with me. We can do as many as we can.
Like a formula.
Okay. So what this formula is telling us is what you're going to do. You get these values by looking at the graph that either they give you, or if they give you equations, you can plug it into Desmos. And the f of x always has to be the function that's at the top. So if you're looking at this first 61, they gave you something that kind of looks like.
Oh, you have to do it twice, right?
Yes, because it switches which one is on top. The 6x is on top here, but not here. And then the other equation is on top. So we're going to have to do it twice. And this is the part that I messed up when I was doing this problem before.
So from -4 to 0 is the first one.
0. Oh, yeah, you're doing this one. So this point is -4, -24, and then 0, 0, and then 3, 18.
But you just focus on the.
Yeah, just focusing on the x. Okay. So Haley started with this piece. Are you guys cool with starting with this piece?
Sure.
Okay. So Haley said -4 to 0. All right, and then the top function is x cubed plus x squared minus 6x.
Minus 6x.
The bottom function is 6x, so we subtract that, so minus 6x. Okay, now what I would suggest doing is combining the minus 6x and the minus 6x.
Mm-hmm.
Okay. All right, now let's look at the right side. So the right side, what are my bounds for my integration interval?
0 to
0,
3.
3.
Good. All right, now which equation is on top?
6x.
Yep. So 6x minus x cubed plus x squared minus 6x. Be
Oh,
careful.
we have to integrate these.
Yeah. That part's not too bad though. For me, it was just plugging in the numbers. I was on the struggle bus with that one. Okay, so then the part that you really want to be careful with is, since we are subtracting this, so I'm going to go ahead and just change my signs here. And then I'm going to combine my two 6x's. So this one is going to look really similar to the other one that we just did. Did you put on laundry? Shug's blanket? Okay. I was just asking. Stop yelling. Oh, gosh.
The 12x.
Oh, yeah. Thank you, Kevin. Okay, so we have this and this. Okay, so we're going to have to do both of the pieces. So go ahead and I'm just going to integrate the first one.
Are we adding these together?
Yes. So this, I think this is the one that messed me up, because essentially 0 is going to be your first value that you plug in. And when you plug in 0, you're just going to get 0. So you're going to get 0 minus whatever -4 is plugged in. So that's, I messed up my sign when I did this before.
What did you get when you plugged in -4?
I didn't do it separately. I did it
Oh,
like when I did it, I plugged in everything and I wrote each piece out because I'd done the problem wrong like 3 times.
So what did you end up getting, Miss Mac? Did you get
937 over 12.
I'm not there yet.
I did not get that.
So if you didn't get it, Haley, it's probably a sign that you messed up, because that's what happened to me. Like I said, I've done this problem 3 times. Do you want me to write it down, Haley?
No, I mean, okay.
Wait, what was the answer?
937 over 12.
I had 343 over 12. That's not
Yeah,
good.
Yeah, you messed up a sign, Kevin, because that's what I kept getting before.
You can move.
Well, we really got an exam tomorrow.
Can you believe it?
Nope.
I can't even.
You're just so sad. Right?
I really think that I'm gonna cry today, because like today was the last day that I was gonna see some of the stats kids and they're graduating, and it's very emotional.
You had 7 over 12.
937 over 12, yeah.
I don't know. Very sad.
So let's see. This is 54. This. This one. Negative. This one is -9. And then this one is where you have to be careful because of the sign. So this is negative 96, but because of that, it turns to positive 96. And then this, wait, is that the right thing? 96, 9. Yeah. And this one, oh no, this is negative 96 here. And then turns to a positive. And then this one is 64 over 3. And it was a negative, so it's going to turn to a positive. And this one was negative 64. Or it was a positive, so it'll turn to a negative. So with this problem, the biggest thing that you have to watch out for is your signs, and the fact that this interval is going from 0 to -4. It's 0 minus -4 plugged in. So whatever you get when you plug in -4, it's a negative of that answer. And that's the part that I messed up. And when I messed it up, I got 343 like you did, Kevin.
Oh, well, I'll be right.
So just, I would make sure that you can do that one in your calculator later. I wouldn't really freak out about it right this second, because it's tricky with the signs. All right, you want to do another one of these? Yeah. Let's get your confidence up.
Yeah, mine's right now. What, Kevin?
Hmm?
Kevin, don't you have like a C?
That's funny. That's really funny.
Well, I have a lot of things to grade. Haley, your mom never emailed me back either.
Yeah, probably kind of has that problem, so.
Well, yeah,
That's
it's,
what's funny.
it's a little too late now to opt out. But I didn't want her to be mad at me.
She's not mad at you. She's just a naturally mad person.
Yeah, so that means she's mad at you.
Okay, so we got this. All right, do you guys want to try? Do you want to try this one on your own to start?
Sure.
Okay. Sorry.
Miss Mac, what did you get?
4.5. That was hard to get consideration. Good. Okay, so do you guys want to do 63 on your own and then we do 64 together, or you want to do both?
63, do we do 2 like the time we did?
No. because it's consistent, which one is at the bottom? You have to.
One on top be negative.
What's the answer?
I don't even do 60 or 64.
You don't do 64?
I'm 64.
Then
You say what?
isn't that something?
64 is I know for 2 hours of trade. Okay. All right.
Are there 63 we want to -2 them? Or we want
It's fair. The function are crossing, which is where they equal here. Okay, so you want to 65 then? Okay, so we got 65. It's the same as 0. So it's just a little more work because you probably will plug it into Desktop, see what it looks like. So like, and this point, when I drew a little bit back, it was 0 and -2, maybe.
Alright, go.
What one side is 2?
Negative and 2, 0.
Is it just
Yep, same thing.
Come on.
The 2x squared.
Oh, this is the same. Oh,
It is. It should break negative half, so you can
so it's 0. It's a -2.
just negative half. Not really that. Okay, no starting everything. Yeah, I wrote it.
Oh dear.
yeah, I think you could have students be able to read that. Did you get 33?
Oh, yeah.
Wow.
70. 65.
Yeah, I got that.
Okay, yay. All right, so 66 through 69, actually 66 through 71 are the same. 70 is more trickier than what's on your exam. So, I mean, we can go over that one if you don't want to, but I think when Miss Kelso was pregnant, was that during when you guys did like trig stuff in pre-calc?
Yes.
Okay, so I'll just show you 70. So what you have to do in 70, in order to make this integration of the cosine squared x easier, you're using something called the half angle formula, which you probably don't remember from pre-calc. It's not on your exam.
Alright.
Why couldn't you just do like cosine times cosine and do the product rule?
Because we don't
Oh, that's not an
Really?
antiderivative. I'm
Yeah.
literally just kidding.
Imagine.
so that 70 is harder than is going to be on your exam, but do you guys want to do any more from 66 through 71? Oh, Elizabeth, I activated your quiz. Are you here? Did I let her in? I don't know if she's in here. Did I let her in? Okay. I don't know. All right. Sorry, did you guys want to do any of the other ones, 66 through 71?
Mm-mm.
Nope.
Nah.
Okay, are you gonna do
Wait, for 71, which one's on top?
the secant squared x
Wait, which one?
for 71? Oh, can you see
You can
that?
see it.
Secant squared x?
How is the secant squared? Oh.
It's on top.
I can never tell like what the radius is gonna be. Like for the shell thing, when you the volume, like with the shells and stuff, I can never tell what the radius is gonna be.
Okay, well, we're gonna go through, if I had to guess, we probably are gonna do most of the rest of this together,
Yeah.
right? Okay, so I'm
Like, I
hoping
have no idea what's going on.
you'll feel a little bit more confident
Dummy.
once we do this. Have you done the notes yet, Kevin?
Which notes?
6.3 and 6.4.
No.
You said no?
Yeah, I've not done them yet.
Oh my God, Kevin, you realize like class is done tomorrow.
Yeah, that's a good point.
I bet you Gary isn't even on chapter 6
No, he's not.
yet.
Okay, So what we're doing for 72 through 74 is, hold on, sorry. Yeah, I accidentally didn't approve you when you were trying to get in. Try to log in now and I'll actually approve you, sorry. Okay.
She not declined her.
So I don't think I did it on purpose. So the formula for this is and we're doing the disk method. Did I say that?
Yeah, I
So
don't know what
formula
that is.
is your 2 bounds, you're gonna have pi, and then you're gonna take whatever function they give you and it's gonna be squared. Okay, so pi comes into play because I'm rotating this, so I'm making a circle. Man, it is raining like crazy.
What time's our exam tomorrow?
From 10 to 2.
Whoa.
How- know which formula to use because there's like 4 or 5 of them.
So the disk method works when you rotate it and there's like no gaps in like where you're rotating around. The washer method is when you're going to end up, like if I had something like this, and if I were to rotate this triangle around, there'd be like a hole in the middle.
Wait, can you move it down?
Oh, sorry. Okay, so this would be the washer, because if I rotate this around, there would be like this hole in the middle of the solid.
Yeah, well, how do you know that?
Because of the way the graph looks. Because like this is my x-axis, right? Okay, and there's this line here, y equals 1 or whatever. And so if I were to spin this triangle around, I would have a gap around here that would be completely empty, and this part would be filled in.
So that's when it's below the x-axis or y-axis, like when it's not the axis, when it's like next to it?
Yeah, it happens when it's next to it. Okay, so the function that they gave us for 72 was negative 2x plus 4. So we're going to plug that into our formula. And to figure out our values for A and B, we're going to look here and here to see where my x is bounded and where is my x bounded.
Wait. It's from 0 to 2.
Yeah. So 0 to 2. We have pi, and then we take our function and we're going to square it. Now, could you do straight up U substitution? Yeah, you could, but let's not. Let's just FOIL this out, distribute your pi, and then integrate it.
So you get 4x squared plus 16, right? Minus 16x?
Minus 16x.
Yeah. Plus 16. And you have pi. Could you do the pi later, like after integrate?
I just went ahead and put it with each of my things after I FOILed it. Sorry, Elizabeth, I wasn't trying to deny you on purpose. I don't know. I didn't mean to. Don't be mad. Okay, so once I FOILed and I distributed my pi, I got 4 pi x squared minus 16 pi x plus 16 pi dx.
If it's 4x, oh, you didn't integrate yet. Oh, yeah.
No, I didn't integrate yet.
Why would you want to distribute, actually?
Why would I want to do what?
Why would you distribute the pi before you integrate?
I mean, I just did it because I don't know, if you wanted to like take it out here and then do it at the end, you could do that too.
That's whatever.
Your answer is going to end up having pi in it. So, I don't know. All right, did you guys all integrate or not yet?
Mm-hmm.
Does the pi just stay there or?
Yeah, it'll just stay there. It's like a constant. So I got 4 pi x cubed over 3 minus 8 pi x squared plus 16 pi x. And then you're plugging in 2 and 0.
It's not even hard.
Do you want us to like keep pi in there?
Yeah, that's what I did. So when I plugged in 2, I essentially just plugged in 2 for the x and I ignored the pi's, but then I wrote pi with each of my answers that I got, and then I put it all together.
Yeah.
Elizabeth, do
Gee.
you guys have kale at Food Line right now? Like a big bag of kale in the very front of the store? It's like market something. It's next to the big thing of collard greens. It's like right on that first wall.
What did you get for the answer?
For me?
32 pi.
Yeah, 32 pi over 3.
Tom.
Yes, Kevin. Okay. Might be on Team Kevin now.
Are you kidding me?
No, I'm totally kidding. Kevin won't take Clark. I don't like Kevin.
Oh, well.
Oh darn.
That's
Kevin.
all right. Yeah, I'm gonna go cry.
Mm-hmm.
All right, let's see. I want to see if you can do number 73 on your own.
And we're still using the same.
Same formula. Do I need to write it down, Kevin? Do you need me to write it down?
And I got it. I think. I don't know what I'm gonna do in the notes.
It's not that hard. It just
You know, but
isn't it?
what are the notes due?
I don't remember off the top of my head. There's too many dates for me to keep track of.
I think they're due like tomorrow.
I mean, that would make sense before your exam.
What?
And we have homework to do, Kevin. Let's go.
I don't have time for that.
You're just gonna take the 0 for the homework?
I literally cannot do it. I don't know where you want me to do it.
You have to go to work after this?
Yeah.
Working at the UPS store. Do you sing to your customers?
I don't have any customers.
Oh. Wait, is it just like a sorting store or something?
Yes.
Do you wear the UPS clothes?
No.
Do you dance
No.
with the boxes?
No.
That would be cool. Do you ever hide in the boxes and then jump out and scare your coworkers?
Yo, you can't open boxes, so no.
Well, I mean, but you could just take like another random box and hide in it.
No,
It would have to be a very tall box. I can't help it. I'm sorry. I'm like crying. I'm laughing so hard about Kevin being tall. It's the little things in life that just, well, not really the little things, the tall things. Okay, all right. I'm really done now. Okay.
That's crazy.
I can't help it. My husband says the same thing. I'm a crazy person.
What's the answer?
I'm gonna write it
Whoa.
down so I don't disturb people.
All right, good.
Is that
Can
the
the
answer?
people just hear us? Or do you like mute your end like then?
What?
Can you choose who hears you and not?
I don't know. I don't know if the people testing, well, I think they can hear me because I just asked Elizabeth about kale.
Lauren, what did you get?
What she
Oh.
has.
I got that too.
Yay.
Oh,
All right,
wow.
Kevin, 3 for 3.
I'm way behind. I'm off my own world for a second.
All right, well, while we let Kevin finish, I need to activate something for dill pickle.
Hmm.
How many are there? 86.
Yeah, but I gave you a bunch on the stuff that you said was difficult for you.
Yeah, well, if we, for 74 and 75, do we just keep the same equation?
74, yes, 75, no. How is
Okay, well, can we
75
just-
different?
You have two equations?
It's upside down.
Oh, wait, no, the y. It has
Yeah.
No.
Okay, well, I don't think Haley wants you to leave, so don't leave. Okay, all right, here is our formula. Now, this is our radius.
Oh.
All right, and this part is our height. All right, and then, so for 76 through 78, we're going about the y-axis. Okay, so we're doing all the y-axis ones first. Okay, so first, I'm just gonna write down the problem. Okay, so one of the things that I did when I did these problems is I plugged into, oh, Dylan, did I tell you it was active? I don't know if I did. It's active. I plugged into Desmos to see what it looked like. All right, can you guys see Desmos?
No.
No. Oh, well, it's still loading. Please move this window. All right, can you see Desmos now?
Yes.
Yeah.
Okay. So all I did was I first plugged in the equations they gave me, y equals 5x, y equals 10x, oh geez. And x equals 5. Okay. All right. So essentially, what you're doing this problem is like this, and it's gonna like the blue line is y equals 10x, and the red line is the y equals 5x. Okay. So you're seeing the 10 one is kind of closer to the y-axis, right? All right. Cool. Okay. So.
Wait, say that again.
So the y equals 10x is the blue line, right? That's here.
Mhm.
And so I just want you to notice on your graph that that one is the one that's closer to the y-axis.
Okay. Yeah.
So using Desmos to help you with that, because they don't always tell you what f of x is and what g of x is.
So which
Make
one?
sure you know.
For the y, we'll go first, and the height.
Okay. Ooh, that's blurry.
So 10x is the one that goes second.
The
since
10x
it's
one was the one that was
not the
closer,
right one.
and this one was
So
further
which
away.
one is the one we use the right?
Hold on. X equals 5. Okay, so it kind of looked like that, but it's not drawing the scale, right?
Sure.
Mm-hmm.
Okay, so the 10x one was the one that was closer to the y-axis, so that is the one that's going to go first, okay? Now for our area that we're integrating, we are going to look and see where our points are, and our points go from where x is 0 to x is, sorry, you probably can't see what I'm pointing to.
5.
5. So we're going to say 0 to 5. We're going to write down our radius. Your radius is going to be 2 pi x. How is it going to be 2 pi x? It's going to be 2 pi x because the 2 pi comes into play, the fact that you're making a circle, and x comes into play with how far over you're going in between the 0 and the 5. So if you go over to where x is 1, or if you go over to where x is 2 or x is 3, leaving this as x will help you calculate that. So it's going to just stay x.
Will it be like that every time for the shell ones?
Yes.
All right, bet.
Unless you're going the other way, then it'll be 2 pi y, but we're going to do something like that. Okay, so then we're going to say 10x minus 5x. Okay, and then before you integrate, you want to do what probably?
Distribute.
Yeah, distribute and simplify. So I'd probably simplify and then distribute.
So whichever one is closer to the y-axis you put first?
Yes, when you're rotating around the y.
Okay, hold on.
So it's just 10x squared pi.
Y first.
Yes, and then you got to integrate, Kevin.
Yeah.
Okay, so 10 pi x.
Dude, this calculator is the worst thing probably ever invented right here. Jesus.
Be 5 pi 5 squared. That's
What'd you get for your before you integrated, Haley?
you get 5x times 2 pi x. So never mind. So it's 10x squared. So it'd be
Yeah, okay.
10 over x to the third. 10 over 3 x to the third. Oh, goodness.
What was the final answer?
I haven't said it yet.
Oh.
I'm gonna write it down.
All right, good.
You got it?
Good. Yeah.
Yay! All right, we'll do the next one then.
Well, 50 pi over 3.
Yes, Haley. LD,
See, I can't.
coming in clutch?
Yeah.
Okay, cool.
Of course.
Was that the appropriate use of that phrase?
Yeah.
All right, you're trying 77.
Okay.
Are we doing all the rest until 686?
Well, maybe not. I don't know.
What do we put for n just as greater than 0?
So when you graph it, you'll see what your upper bound needs to be. So your lower bound is going to be 0.
Huh. Oh.
Did you say huh, Kevin?
Oh, how are you supposed to find the intersection right there?
Are you using Desmos or are you using a real calculator?
Desmos.
Okay. If you're using Desmos, you can just click on it.
I'm trying to. Oh, there you go.
Desmos is
Thebomb.com.
Yeah.
All right, while you guys are doing that
Whoever
one,
made it.
I'm gonna go pee.
Nice.
All right. Kevin,
What?
should I run downstairs and get my?
Answer what?
I run down to the mailbox right now.
No.
I think. So it would be 2 pi x 4 plus 3x minus x squared. Is that what you got?
What?
Did you get 2 pi x and then it's 4 plus 3x minus x squared?
Yeah.
You'll have the upper bound is 4.
Yeah. I have 4. And then we
Which one do you have closer to the x-axis?
4
I think
plus
since
3x, right?
I think since it's on top, is that finger first?
Well,
It's
Because
closer
one
too, but
switches, but I guess we're just looking at that area. I think it's that one.
wait. Since it's only x is greater than 0, it's a lower bound 0?
Yes,
Yeah.
lower bound is 0.
Okay, good.
so did you get before you integrated it? It'll be 8 pi 6 pi x squared minus 2 pi x cubed.
Say, I didn't, before I
Yeah.
integrated, what did you say?
Before you integrate it, is it 8 pi x 6 pi x squared minus 2 pi x cubed?
Yes,
Can you write down the answer?
No.
yes.
Huh. That's not what I got.
1.
Oh,
Pi.
that's a problem. Silly.
All right. Almost done this night. I'll get there in a second.
I'm not frustrated. I'm hungry though.
I'm starving.
You get 64 pi? Oh my god.
I believe I'm about to get that. Hold on.
Dub, Miss Mag.
Cha-cha.
Go. I got it too. I just forgot to integrate in. That's
LD?
not good.
I got 75 over 2.
Oh,
2 plus.
we're doing 78.
No, I was thinking like we could go to the other ones which are going around the X instead, if that's okay with you. But if you would like to do 78, we can.
No, that's
Nope.
fine.
Okay.
I'm so hungry. Oh my god.
Okay. So 79. These ones are different because now we're going around the Y. So your formula, it looks really, really similar.
This is about the y-axis. You mean the x-axis?
Yeah, did I say Y? I'm sorry. I meant X. I think I did say that. Sorry.
Oh, you just changed it.
Yeah. So now our radius is Y because since we're spinning around this way now, which you probably can't see that because my pen is just moving, the Y changes our radius. So pretty much the same like we were doing before. And when you graph these in Desmos, you're gonna have to put the x equals first. Otherwise, the calculator is not gonna know what to do.
What's that? Oh, x equals -3y.
X equals what?
-3y.
3 square root y, Kevin.
Oh, oh yeah. Why was I looking at that?
Mine don't really intersect.
Really?
Mine do very. No, they don't.
They don't what?
Like they touch at 0, but that's it.
That's okay. Because we're gonna spin the one around the other one. Zero and one.
Oh,
Do you guys see it? Do you need me to share my Desmos screen?
Yeah, you gotta share it.
Okay.
-1, 2. I mean -3.
Is this the right screen? Yeah. Can you guys see Desmos now?
Not yet.
Okay.
Yeah. Mine doesn't look like that.
Did you type
Mine
it
looks
in?
like
Mine didn't either.
Did you type it in correctly?
Oh, am I supposed to also type y equals 1?
Yes.
Oh.
But Miss Mac, isn't another intercept at -3?
Yes, but we're not we're not gonna care about that for this.
Yeah,
We're only
mine's
gonna
something
care
like that.
about the 0 and the 1 for the y.
Mm.
Essentially, I mean, you could kind of think of it as it's going to be spinning around on this, the blue one is like a thing. If you think 3D, I don't really think 3D. So, okay, let me.
So everyone's closer to the X now?
Yeah, so hold on, I clicked on something else. So we are going to do the one, well, it's not, you can't really use the closer rule. You're going to use which one is on top for this one. So this, the 3 square root of y, the red one is on top. So that's going to be my f of x in this case.
3 square root y minus.
What are the bounds though?
3y?
0 to 1, because now I'm looking at the y coordinates.
Oh.
Instead of the x coordinates.
Man.
Do we use, so g of x will be the -3y?
Yes. So you're going to minus the -3y.
But there's no intercept for -3y on 3. Like the intercept's on y equals 1. Why don't we use y equals 1?
We are doing y equals 1. What are you asking me?
But we don't. Why don't we put y equals 1 into our equation? Like, why are we just forgetting about that one?
Oh, because that's just like a bound that they're giving me. So we're essentially trying to find the area where all 3 of them kind of like corral the cows. So like the cows would be, because your graph looks like this. We're finding this area right there. Okay, so the first part you should be okay with. It's going to be 2 pi y, right?
Mhm.
Our bounds are going to be from 0 to 1,
Mhm.
because that's where my y's are going, 0 to 1, 0 to 1. And then f of x is the 3 square root of y, and g of x is the -3y, And just like before, you want to simplify as much as you can before you try to integrate.
Thanks. Oh, but you can't. What?
What do you mean you can't? So what I did was I changed this to be 3y to the 1/2 plus 3y, right? And then I distributed in. So 6 pi y to the 3/2. Yeah, there you go.
All right, simplify that.
What do you mean? Oh, you can't
I thought you
combine
could.
these.
That's possible.
All right, now you can integrate. You keep forgetting to integrate, Kevin. Integrate.
I did.
Okay, good.
Oh. Can you write down the answer?
I can.
Dub.
All right, Dub, do 80.
Ew. What? And it intersects way on out there. Oh. What?
Sorry, I got a call.
Who was it?
It was for a scholarship.
Oh, did you win it?
Yeah.
That's exciting, LD.
Thanks.
Good stuff, Lauren.
I'm trying to see what y'all did.
You can't see
What
because
are
the
the
cat's in
balance
the
for?
way.
80.
So
Oh,
What are you saying, Kevin?
Like the balance for 80.
I got 0 and 4. Chloe, you were standing
4.
in the computer. Come on, move out of the way.
You get 4.
4?
Oh, it's negative. Okay, never mind.
wait, how'd you know which one went first?
It's the upper one. This one.
So the upper one for this one would be the 4y squared.
Yep.
How do you know when it's above the x-axis or below?
What do you mean? Kevin, I didn't understand your question.
I thought we were looking like intercepts above the x-axis. Like you get a spline now, but
Your
it's up,
intercepts
it's up.
above the x-axis?
No, we're good. We're good.
So I don't understand.
You didn't know that you could have intercepts below the x-axis. Like, never mind. Yeah, just never mind.
Lauren, are you still looking at 79?
Yeah.
Okay, that's fine. I won't move it.
Wait, so is it negative 4y on top?
No, 4y squared is on top.
I don't want it.
I just see a little tail wiggling back and forth. Boop, 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 boop.
Minus 6. All right, I'm fine. I just don't understand how you knew which one to put first in the equation.
Whichever one is the upper equation, which in this case it's this guy. But graph 80 and look at that one. That's the one that Haley and Kevin are working on now.
Oh my gosh. Can you write down the answer?
Yeah.
Yeah.
Kevin, what'd you get?
Well,
Hold on.
Lauren hasn't even done it yet.
Dude, stop.
So is the lower bound always going to be 0?
In the last two it was.
Like, and this one is at 0?
Yeah, and this one is also 0. And in the next one it's also 0. Maybe I just picked all problems that were.
But how do we know when it's 0?
You're looking at the y-axis this time instead of the x-axis.
Tub.
Yeah. Oh.
The best.
Well, what? So the what?
Okay, so I didn't write down the graph for this one. Okay, so we had x equals 4y squared.
Yeah.
And x equals negative 4y. And y equals 4. Oops, y equals 4. Okay, so let me show you, Lauren. Can you see Desmos?
Nope. Yep.
Yeah.
Okay, so in this case, the red equation is above, and that one is the 4y squared. So that's the one that goes first. And then our bound is from 0 to 5 for the y.
So we know it's from.
You know what? It is always going to be 0.
No.
Because we're rotating this whole thing around the x-axis, so it has to be 0.
Is
Wait.
it always for the rotating around X and Y?
For y, I don't remember. Did we use 0 for all of those ones too? 0, 0, yeah. Yeah. So the lower one is always going to be 0. Look at Lauren Douglas noticing things.
Wait. So Miss Knight,
So
we
Lauren
mean
Douglas.
we mean that one's above it because like when we turn our heads, it's above it. But we really mean like it's to the right, right?
Yeah, I guess you could say to the right. That'd probably be more accurate. Okay. Did you want to finish that one, Lauren Douglas?
Y'all you can. What's the answer?
2048 pi over 3.
Okay.
Okay.
For 81, is it just going to be the one equation? Like you don't have a minus g of x?
Yeah, because it's just essentially 0.
Okay.
You want to do that one real quick?
I mean, not really.
Okay, then you can do it later. Okay, 82 through the rest is kind of mixed up a little bit in terms of how you do them. So you want to do 82?
Yeah.
Okay.
I keep not getting the right answers, Miss Knight.
You keep on getting the right answers or not getting the right answers?
Not. Like for the one before this, I didn't either. Plus, the upper bound was 4, right?
For the last one that for number 80, yeah.
So after you integrated it, was it 2 pi y to the 4th plus 8 pi over 3 y to the 3rd?
8 pi over 3 y to the, yeah.
Then you just plug 4 in, right?
Yep.
I don't know what's wrong with my phone.
So I got, when I plugged in 4 to 2y to the 4th, I got 512 pi. And when I plugged into the 8/3, I got 512 pi over 3.
Okay. Okay, 512.
Okay, so for this one, you're going to start the same thing with drawing this out. Okay, so we have y equals x, because I've got this from Desmos, all right? Y equals x. Y equals 0. Where's y equal to 0? Yeah.
Yeah, that's it.
Yes.
Yeah, access. Access, not access.
Okay.
That's y equals 0. And then we have x equals 2 and x equals 6. We're trying to find this area.
Y equals
I mean,
X,
volume.
X equals.
Okay, so then the next question is, are we rotating around the x or are we rotating around the y?
What do you know?
It says on the directions.
Oh, X.
Yeah, the x. Okay, so that means essentially what I'm going to do is I'm going to take this thing and I'm going to go. Okay, so then the question is, how are we going to do this problem? What method are we going to use?
Shell.
2 problems up. 2, 1.
You think the shell method?
Yeah, because isn't it gonna be a hole? No, we need washer.
What?
We would need washer if we were going from 0 to 6, because then there would be, well, there wouldn't even be a hole. There would only be a hole if we were going around the y-axis and we were going from 0 to 6 instead. But this one is nice because we're going from 2 to 6. So all you have to do for this problem is kind of like the first ones that we did. You're going to have your bounds of 2 to 6. I'm getting that from my x's here. And then pi, because I'm spinning around, so it's going to make a circle. And then, yes, we're going to take our function and square it. So it is going to be x squared, just like Haley said.
How do we know we have to use that one instead of the one we just did?
Yeah.
So as you pointed out, Lauren, for all of the shell ones, the lower bound was 0.
Okay, so if the lower bound is not 0, use the pi.
And you know, the other thing too, I think when we're doing the shell, you always have like 2 equations and they're kind of like wonky. Whereas here, since one of them is the x-axis, it's a little bit nicer. Whereas shell, I would have something like this and maybe like this or something. So it'd be weird.
So how do we know what's f of x? It's just the first one they give us?
Yeah.
Yeah.
So is the answer 32 pi?
I did not get 32 pi.
What?
Do you get 208 over 3?
I got 208 pi over 3. Yes.
Dub.
What? Oh, I didn't integrate. Sorry.
All right, Kevin.
That's my bad.
All right, Kevin, go ahead and do 83.
Uh-oh.
Uh-oh. Uh-oh, who just got up? Guess who's getting up, Kevin?
Clark.
He is. Clark, Kevin wants to see you.
That's not what I said.
You said 208 pi over 3?
Yeah.
Yes. Did you get that, Haley?
Nope. I mean, I didn't try it. I just remembered what you said.
Oh, okay.
208 pi over 3?
Yep.
Yeah. So we're doing the next one?
Yeah, you're doing the next one. I think, are all the rest of these the same? Let's see.
All right,
Yeah,
I got it.
all the rest of them are the same.
So they're the same method?
Same method.
We're doing 83 right now?
Yeah.
Y equals square root x. Y equals 0. X equals 0. X equals 7. So is the bound from 0 to 7?
For 83, yes.
How do you get that?
From 0 to 7.
Oh.
So the fact that they gave me the x equals 0 and x equals 7.
Oh. Oh.
So like without doing 84, Kevin Harris, if you just look at it real quick, what would be the bounds for integration?
0 to 6.
Yep, good job.
So what's the answer? 49 pi over 2?
Yes.
Whoa, hold on now.
Mm-hmm. Yeah,
We're
Miss
doing-
Mac, I feel like I'm not gonna know when to use this shell method.
Well, on the shell one, I said use the shell method.
And then the washer,
Wait, which
We
one's
I
the
don't know, did I
shell?
not give you any washer ones on here, I guess?
yeah, I don't think we've done one with the washer method.
Yeah, we did. I think.
No, the first two were the
No, I
same.
think I just drew a picture. So, where's my book?
I thought 72 was washer.
Was it? I don't remember.
Let me look.
Yeah.
No, 72 is the same method we've been doing.
Oh yeah.
That's different.
I guess we don't have to do wash on loop cam. Dub.
Do we?
Well-
I don't know. Let me check. Now I'm paranoid. Ugh, Chloe is laying on the exam. He's coming, Kevin. He's coming. There might be a washer one. I can't tell by just looking at the formula. But let's just look at the formula, the generic formula real quick before you guys go.
Which one is the shell method?
That is, oh, I got rid of my scratch paper. It's the one where it's like the 2 pi, either x or y, times.
Okay, then what's the other one?
So this is shell. The disk is pi f of x squared, and then I'm looking at washer because I don't have it memorized. Okay, so that's the one where you just have to subtract the two functions.
Oh.
So it's like this, but you have to do pi times f of x squared minus g of x squared.
Oh, yeah.
So you're essentially, whatever the function that you have, like let's say I had something that looks like this. That's not a very good picture. And
We can't see.
oh, sorry. So let's say I was gonna go, oh, that's a really bad picture. I'm gonna draw another one. Okay, and let's say, okay, I wanted to do from x equals 1 to x equals 7 or something. And if I was spinning around the y, I would end up with a hole here. Right? So that's why it kind of looks like a washer. So you'd be doing whatever the outermost function is minus the inner function of the washer part. I don't know if I drew this very well. Clark, get out of the sink.
So that's the one where you use the right mode?
Yeah. Clark, get out of the sink. Clark, get out of the sink.
It's my luck when I finish.
Okay, yay. Do you want to do the other one?
I have to do the notes for the other one.
Okay. I'll message you for a time for later.
Okay.
Okay. Get out of the sink, Clark.
Are we done?
Yeah, I think we are done unless you have more burning questions.
I mean, I still don't really understand the washer, but I'll just try to figure it out tomorrow.
Wait,
Well, like I said,
Yeah.
I don't know just by because I just have the exam, not the answers in front of me. And so I can't tell by looking at it if it's the washer or if it's the other one.
Yeah, well, if it's the washer one, would you tell us, like, to use the washer since that one's kind of harder to know? Like, when you,
I could be persuaded if and only if I get another cake. I'm
The
just kidding.
same-
I'm just kidding. That's like bribery.
but if I were to hypothetically make you a cake, would it be the same kind?
Would it be the same kind? I mean,
Yeah.
that cake was so good. Like, did you make the
I like
icing
cake.
yourself?
Yeah, I made it all.
No, she bought it. I literally saw her buy it from the store.
Kevin, it was too ugly to be bought.
It was so good.
It was pretty ugly.
All right, bye, Miss Mac.
All right, bye. I'll see you tomorrow. How do I stop sharing? Stop sharing.
And bye, Miss Mac.
Okay,
Studying my
bye.
Bye.
3 and 4 homework.